Hello my dears, again very good morning to all. So I think in the last night we discussed about some important facts regarding the transients and what is meant by a transients and how can we derive the equations for what inductor voltage, inductor current, capacitor voltage and capacitor current, etc. I hope you have a little knowledge, right? Not that much knowledge, I know that, because it's very difficult portion, I know that. So I think somehow you have an idea, right? What do you mean by a transient and how can we start solving a problem? Okay. So by doing more and more problems, now in this class also we will do more than 5 to 6 questions. So at that time definitely you will have a good knowledge of transients. And definitely you can try a problem. If you have some problem in your hand, at least you can try. Definitely you can try. Okay. That confidence will be there after doing these questions in our class. Okay. So again I request all of you to please share our videos to your friends if you really feel it is contentful and it is really helpful to you, because I already told you, my ambition or my aim, actually my teaching is my ambition, and my aim is that many students here in our country who do not capable of paying a huge amount in coaching classes and take for some course regarding electrical and electronics engineering examinations. So my aim is to reach this video to that level, to their level, and they start learning. At least they will have some basic foundation. Even though they can't prepare for what gate level or ISRO scientist level examination from my classes, but my aim is just making a good base, make a good idea what the subject is. Okay, and the rest is in their hand or in your hands, because whenever you start learning the basic, after that you have to try more problems, you have to read a lot, then only your knowledge will be boosted, and then only higher level examination will be easy for you, right? Otherwise it will be very difficult. So my aim is that. So please share to your friends, relatives or family members. They are also get benefit, right? So let's move to a problem that is the continuation of last class problems, a new problem, so that the idea of transients and how can we solve will be more and more clear. Okay, Okay, my dears, write a question. One by 3 Henry, 3 ohm, 2 ohm, 10 volt. Find IL of t. The question is, find IL of t, that's all. The question is find IL of t. Find IL of t. Okay, how can we start? We know the basic equation of IL of t. It is can you tell me, is this a source free or source full RL circuit? In this figure, see the diagram, at t equal to 0, the switch is open. That is the meaning of the arrow towards top side. The meaning of this is that at t is equal to 0, the switch is open, which means under steady state condition the switch was closed, right? Did you get the idea? At t is equal to 0, the switch is open. At the initial condition, or we can say under steady state condition, the switch was in this position, that means in closed position. That's all. That means simply it's a short circuited condition. So we know the basic equation for IL of t as, what is that? So if it is in short circuited condition, means this will be shorted, and there will be of course the inclusion of what source will be there. So it is definitely a sourceful RL circuit, right? Sourceful RL circuit. So we have the equation for IL of t in sourceful RL circuit is nothing but IL of 0 minus IL of infinity 0, right? IL of 0 minus IL of 0, infinity e raised to minus t by tau plus IL of infinity. Is it correct? Is this correct? So we have to know the value of what? IL of 0, IL of infinity, and tau also. Tau is nothing but beta, tau is nothing but L by R, right? Tau is nothing but L by R. Here it is, no? L by R under steady state condition, right? L by R under steady state condition or infinity condition, that we will discuss. And L by R means, what is the value of R here? That means at t is equal to 0 itself the switch was closed, right? I mean it was open, right? It was open. That means there will be an inclusion of this 5 ohm. That is 2 ohm plus 3 ohm will be there all the time after t is equal to 0. That is the meaning. After t is equal to 0 or at t is equal to 0 the switch was opened, right? Opened. That means after t is equal to 0 up to infinity time tak, what happened? There will be 3 ohm resistor because it is open circuited. So there will be the effect of 3 ohm all the time. So R will be equal to, or R, its L by R will be what? Simply 1 by 3 into 5. 1 by 50. So now you got the value of tau or L by R, but the remaining thing, see, IL of 0 minus and IL of infinity we have to find. Let's see how can we find it. See, okay, see, initially when we have to find IL of 0 minus means at t is equal to 0 minus you have to start the analysis. At t is equal to 0 minus is nothing but beta, the initial condition, or we can say that the steady state condition, right? Steady state condition. At t is equal to 0 means we changed the condition of switch, that means transients included or transients happened, but just before that is called that t is equal to 0 minus, that is the steady state condition. At t is equal to 0 only what? The interruption occurred in the circuit. So before t is equal to 0 is considered to be the t is equal to 0 minus, that is nothing but the steady state condition or stable condition. So at t is equal to 0, what I told, at t is equal to 0, inductor will be what? Inductor is considered to be what? Short circuited, right? Short circuited, and C should be what? Open circuited. C is open under steady state condition. What is the meaning? This L should be short circuited and C should be open circuit, right? I already explained what is the reason. Okay, and now in the circuit there is only inductor, right? So we have to draw the figure like it is 10 volt and it is 2, and t is equal to 0 minus means what happened? There is an inclusion of 5 ohm, right? I mean this 3 ohm also there, right? 2, 3 ohm, 2 ohm, and inductor is nothing but what? Short circuit, and that current is nothing but IL of 0 minus, correct? That current is nothing but IL of 0 minus. Inductor is short circuited means why we have to take this condition t is equal to 0 minus? We have to know if there is inductor and capacitor, we have to know the initial inductor current plus initial inductor, I mean capacitor voltage. That is the only aim of doing t is equal to 0 minus condition, that is the initial condition. Because I already explained that a capacitor is represented by a capacitor in series with a voltage source, and inductor is represented by an inductor in parallel with a current source. So for that representation, we have to know the initial values of current in inductor, initial value of voltage in capacitor. That is the meaning of doing this t is equal to 0 minus condition, or in other words IL of 0 minus we have to know, right? For that we have to do this. So this current is nothing but IL of 0 minus. What is the value of IL of 0 minus? It is nothing but 10 divided by 5, which is nothing but 2 ampere. So now you got the value of IL of 10 by sorry, okay, really sorry. At t is equal to 0 only it is which is what opened, right? Before that the switch was in closer position. Switch was in closer position, right? So if the switch is in closer position means this will be short circuited, right? This will be short circuited, right? This is short circuited means there is no effect of this 3 ohm, right? In this figure there is no effect of this 3 ohm. Really sorry. So IL of 0 minus is nothing but simply IL of 0 minus is 10 divided by 2, which is nothing but 5 ampere. Which is nothing but 5 ampere. Which is nothing but 5 ampere. Did you get the idea? Did you get the idea? Did you get the idea? And now we have to find. The value of what? The value of the IL of infinity term, right? We found out this value IL of 0, we have to find IL of infinity. So for that, we have to consider the diagram at t greater than 0. T greater than 0. So at t greater than 0 means from just after t is equal to 0 up to infinity tak we can say that this is t greater than 0. T greater than 0 means whenever we turn off the switch at t is equal to 0 and after that up to infinity we can say that it is a t greater than 0 condition. So after t is equal to 0 means the switch is open, right? The switch was open and there will be the inclusion of 3 ohm after t greater than 0. So the resultant circuit diagram will be what? The resultant circuit diagram will be, listen carefully, this will be there, right? So 10 volt will be there and this 2 ohm will be there and this 3 ohm also will be there and inductor is represented by beta, inductor will be there and the inductor is represented by an inductor plus a current source in parallel. That is nothing but IL of 0 minus, right? This is a representation of inductor, right? And this is nothing but 1 by 3 farad, right? 1 by 3 farad. Sorry, 1 by 3 Henry. Unit is Henry now. So 1 by 3 Henry. This IL of 0 minus, you have the value, what is that? 5 ampere. 5 ampere. Correct, 5 ampere. Okay. So now you have the diagram of this figure at t greater than 0. But we have to find the value of IL of infinity, right? So we have to consider the diagram at t equal to infinity. At t equal to infinity. So what is the meaning of at t is equal to infinity? This is just after the switch was opened. This is the diagram. There will be inductor, the equivalent circuit of inductor I drawn, and at t is equal to infinity means what was the condition at t is equal to infinity? We know t is equal to infinity is another steady state condition. The steady state condition is nothing but capacitor will be under steady state condition, capacitor will be open circuit and inductor will be short circuit, correct? Capacitor will be open circuit and inductor will be what? Short circuit, correct? So this figure reduces like, this is 10 volt, there is no change in that. There is also no change in 2 ohm and 3 ohm, there is no change in that. This will be like short circuited. Five ampere, right? 5 ampere. See the figure carefully, beta. See the figure carefully. If a current source is short circuited means, definitely the current source having some resistance, right? Definitely the current source having some resistance. This is also some resistance. If it is short circuited means, this also considered to be a short circuited condition. That means the effect of this 5 ampere will vanish there because it is short circuited. So the effect of 5 ampere will not be there after short circuiting, after short circuiting. That means if you have a current source, it having certain resistance, right? This resistance in parallel with zero resistance. So the effect of effect will be what? Simply a short circuited condition. Simply a short circuited condition. And at that time, there will not be the initial current, but there will be a final current, because it's short circuited now. So there will be a final current. It will not be that initial current there, because it is short circuited condition. So that current should be nothing but IL of infinity. That current is nothing but IL of infinity. And IL of infinity is nothing but IL of infinity is nothing but 10 divided by 5, which is nothing but 2 ampere. 2 ampere. IL of infinity is nothing but 10 divided by 5, which is nothing but 2 ampere. Okay. So now you have in your hand IL of 0, IL of infinity, and tau also. Tau is nothing but the time constant, which is we already found out. Tau is always calculated for t greater than 0 condition. So t greater than 0 condition means the switch will be open. So 2 and 3 will be there. So with respect to the inductive perspective, the inductor feels a total resistance of 3 plus 2 ohm, that is the 5 ohm. So the factor R will be equal to what? 5 ohm. And L is nothing but 1 by 3. So 1 by 3 into 5, 1 by 15 is the tau value. So now you have IL of 0, IL of infinity, and tau. Okay. So I will once more say, I will say the steps. First you have to find the initial parameter of inductor and capacitor. Initial parameter in the sense, initial value of current in an inductor, initial value of voltage in a capacitor, because a capacitor always contains some charges. Due to that there will be a voltage. An inductor contain always some but inbuilt magnetic field in it. So due to that there will be a tendency of current which is flowing in the inductor. So initial conditions of inductor and capacitor we should find. So that is why we have to take first instant itself. That is first instant of doing this problem is nothing but at t is equal to 0 minus condition. So at t is equal to 0 minus means it's a steady state condition. So inductor and capacitor should be in certain manner. Inductor is short circuited, capacitor is open circuited. Keeping that in your mind, you have to draw the circuit. At t is equal to 0 minus means the switch was in closed loop condition. The switch was in closed loop means this is short circuited. So there will not be the inclusion of 3 ohm, because this short means this is also short. So it only contains 2 ohm resistor. So simply 2 ohm and I. So you find out the value of IL of 0. Okay, boss. Next aim is we have to find IL of infinity. So for that you have to generally draw the figure at t greater than 0 condition. So t greater than 0 means after t is equal to 0 condition, right? After t is equal to 0, the switch was in closed position, open position. Open means there will be an inclusion of 3 ohm because it is open. So there will be 2 plus 3 ohm will be in the circuit for all the time. So 10 volt, 2 ohm, 3 ohm, and inductor is always represented by an inductor in parallel with a current source. Capacitor is represented by a capacitor in series with the voltage source. Okay. So inductor in parallel with the current source, and you have to do for at t is equal to infinity condition. This is just for at t greater than 0. This is just after t is equal to 0 condition, right? Just after, not soon after certain time actually. Okay. Soon after means it will be t is equal to 0 plus condition will be there. Soon after t is equal to 0 means t is equal to 0 plus. T greater than 0 means it is after settling, after what that transients are over, no? That condition is termed as t greater than 0 condition, not infinity level, but t is greater than 0 means after the transients get settled, right? So 10 volt, 2 volt, and this will be the diagram. And at t is equal to infinity condition, again another steady state condition or stable condition. So that stable condition is nothing but inductor will be short circuited and capacitor will be open circuited. So keeping that in mind, we draw again the figure. This is short circuit means there will not be any effect of that 5 ohm, that 5 ampere there. There will not be any effect of 5 ampere because it's short circuit. So what happened means we have to redraw the figure by keeping that in mind. So that current is termed as IL of infinity, and that IL of infinity is nothing but 10 divided by 5, which is nothing but 2 ampere. That is the meaning of this whole analysis. Okay, so now you can find IL of t is nothing but IL of 0. What is the value of IL of 0? It is nothing but 5, right? 5 minus IL of infinity 2 into e raised to minus t by tau. Tau is nothing but what, beta? tau is nothing but 1 by 50, right? Tau is equal to 1 by 50, no? So T by tau, right? T by tau 1 by 15. 1 by 15, 15 go top, plus IL of infinity is nothing but 2. So it will be more clearly, it will be what? 3 e raised to minus 15t plus 2. So that is the final answer. Is it clear, beta? This is the final answer. IL of t. I will say again, I mean, these questions are no, this is actually a lengthy question. If the examination is very difficult, then only a portion of this answer will be asked, not all the answer. The examiner may ask only to find the initial current, only to find the tau, or in terms of RC circuit, another tau, right? That also you have to find, time constant. So a portion of the circuit will be asked, not all this, because it will be very lengthy now and very difficult too. So, but if you do such a difficult question now, it will be definitely easy. If you see that question, a part of the question in the question paper, then you will feel very happy there. So that is the aim of doing such difficult question in our class. Okay. So that's all about that question. So let's move to another question. And one more explanation I will give you for removing that. This was inductor and this was 2.5 ampere, right? So why I removed that 2.5 or 2 ampere? I think 2 ampere, right? 2 ampere, right? I think 2 ampere. Or sorry, 5 ampere, right? 5. But was anyway, it may be 2 ampere or something. At the final condition, at t is equal to infinity, what happens is the inductor gets short circuited, right? Inductor gets short circuited. If it gets short circuited means it is in stable position, right? At that stable position, there will not be any inductive action because the inductor gets saturated. The inductor got enough charges or inductor got enough current through it. That means the inductor will not act because there is no transient and all. At t equal to infinity means there is no transient and all. The inductor can simply short circuited condition. That means it simply act as a resistor. If it simply act as a resistor, then there is no meaning of that initial charge or initial current in it, because initial current and initial charge is only considered when it acts as an inductor. If this act as a simple resistor, then why we have to consider this condition? That is also another explanation for why I remove this 2 ampere at t is equal to infinity condition. Okay. In many way you can analyze the circuit. Analyze the condition. Okay, beta. So it's up to your level. How can you think and imagine? Okay. So let's do another question. Beta. Okay, find d by dt of IL of t. at t is equal to 0 plus. Oh, what a question. See beta, this is the question. This is the question. Okay, clear? So now you have to find, d by dt of IL of t. Okay, at t is equal to 0 plus condition. My God, what a question is. It is a combination of RL and RC is there. So of course that equation doesn't work here. That equation, no, IL of t is equal to IL of 0 minus IL of infinity e raised to minus t by tau plus IL of infinity, and for capacitor also RC circle another equation is there. That is VL of 0 minus VC of 0 minus VC of infinity, right? That condition or that equation only works when it contains pure RL or RC not the combination. So we can't think about that two equation. Okay, leave it. And we have to start the analysis, right? So definitely our analysis will start from at t is equal to 0 minus condition. At t is equal to 0 minus condition. At t is equal to 0 minus condition means, better listen carefully. What is the meaning of that? This t at t is equal to 0 only this is come into play. That means the switch is closed. Before the switch was open. So at t is equal to 0 minus means the switch was open condition, right? So and also at t is equal to 0 minus means inductor will be short circuited, capacitor will be open circuit, because that is a stable condition, right? T is equal to 0 minus means it is a steady state condition. I already explained that. So our circuit will become, listen carefully, our circuit will become at t is equal to 0 minus means the switch was in open position. Open position means there will be a 40 ohm. There will be 40 ohm. There is no doubt there in that. And see, the inductor will be short circuited, 40 ohm. The capacitor will be open circuit. And that is the voltage of capacitor is nothing but VC of infinity, and the inductor is short circuited means that is the current which is IL of 0 minus. IL of 0 minus. Correct? So that is the aim of doing this IL is at t is equal to 0 minus condition. So at that time the current will carried by this path will be IL of 0 minus, and this path the voltage across that capacitor, because capacitor is open circuit, no, it is VC of 0 minus. Okay, VC of 0 minus. So what happened? This is also 40, right? This is also 40. This is open circuit, right? There will not be any flow of current, right? VC of 0 minus across this means if there is no current in the path means there is no need of this resistor, because there is no flow of current. So we can say that this VC of 0 minus is nothing but simply we can draw like this. Simply we can draw like this. This is VC of 0. This is VC of 0. Because we don't need to include that resistor, because there is no flow of current through that. So now our aim is to find IL of 0 minus and VC of 0 minus bus. So how can we find IL of 0 minus beta? IL of 0 minus, how can we find IL of 0 minus? This current is nothing but only this is the path, right? This is open, no? So only this is the path, right? So it will be 200 divided by simply 40 plus 40, that is nothing but 80. 10 by 4 or simply 5 by 2 or 2.5 ampere. So that is nothing but the IL of 0, 2.5 ampere. Then what is VC of 0 minus? VC of 0 minus. What is VC of 0 minus here? VC of 0 minus is nothing but this voltage, right? This voltage. So this voltage is nothing but the voltage across this 40 ohm, right? The voltage across this 40 ohm, right? Voltage across this 40 ohm is nothing but, apply voltage division rule here, that is nothing but 200 into 40 divided by 40 plus 40 is nothing by 80. So it will be 2 and it will be 100 volt. So now you have in your hand what are in your hand. You have IL of 0 minus and VC of 0 minus. Did you get? Did you get? Do you have any doubt? Do you have any doubt until now? Okay. And we are again far away from our destination. Step by step we will do. So we have to do, what is that? Next is nothing but at t is equal to or t greater than 0 condition. At t greater than 0, we have to include all this, right? We have to include all this. So at t greater than 0 is nothing but the switch is suddenly closed. If the switch is closed means there will be a short circuiting of 40 ohm also, right? There will be a short circuiting of 40 ohm also because it is short, right? This is short means this also short, right? So the remaining figure will be simply 200 volt beta listen, and there will be thus 40 ohm. There will be an inductor in parallel with what beta? In parallel with the current source. The current is nothing but 2.5 ampere, right? 2.5 ampere, and the inductor value is nothing but 2 Henry. And again in this path there will be again 40, and there will be capacitor in series with the voltage, right? In series with the voltage which is nothing but 100 volt. So this will be the exact figure, right? This will be the exact figure at t greater than 0 condition. Is it clear? Now we have to move for t equal to this t greater than 0 condition means it is actually equivalent to t is equal to 0 plus condition also, right? T is equal to t greater than 0 means not equal to t equal to 0 plus condition, just after the t is equal to 0 plus condition, right? I mean there will be not settled actually, t greater than 0 means not the parameter settled, but they start settling. That means there will be inductor, there will be capacitor, there will be equivalent, all will be there. And now we are going to at t is equal to 0 plus condition. T is equal to 0 plus, very important. This is in this question only we are discussing t is equal to 0 plus first time, for the first time. Okay. So t is equal to 0 plus is very important here, and that condition is nothing but beta soon after the transients happened. At t is equal to 0 means transient started. T is equal to 0 plus means soon after the transient start. I mean there will be the inrush effect of transients at that time. T is equal to 0 plus. Is it clear? At that means inductor will be at that time, very important, inductor will be open circuited. Capacitor will be short circuited. Very important concept. That means at t is equal to 0 plus, inductor will come into play its maximum what? Anger, right? Anger. Because at t is equal to 0 plus means suddenly the switch was what? It is closed. I mean there will be a disturbance in the system, there will be some frequency mismatching, there will be some what change in the parameter and all. So whenever there is a change in parameter and or current, the inductor will come into play with the full force, right? The inductor will come into play with the full force. That means stop, I can't afford this, I can't afford this, because you are changing so many times, you are changing with very in fast manner, you are changing, I can't afford this, oh my god. That is the nature of the inductor at that time. That means the inductor will be open circuit, I can't afford this. And capacitor will be collapsed, I don't know what to do, array, let me give some time to store my charge, then only I can act accordingly. But the interest changes make the capacitor simply short circuited. I can't afford, you do whatever you want. The capacitor will be in that manner. That is a very important thing. That's very funny and interesting thing, beta. That's very funny and interesting thing. Inductor will be open circuit and capacitor will be short circuit. Very important concept, beta. Very important concept. Actually, when I was a student in my BTech classes, I don't know the condition, how it is. The staff or teacher will simply write at t is equal to 0 and it will be open, and what is the physical meaning? But I started thinking and I arrived at a conclusion like this. So at t is equal to 0 means maximum inrush will happen. So maximum rate of change will happen the inductor can't afford. The inductor will be, my God, you can't come here, you stay there, because if there is maximum rate of change, it will maximum opposition will be there by the side of inductor, right? That is the nature of inductor, right? Inductance is the property of opposing the rate of change, right? Opposing maximum force means open circuit. I can't follow anyone. That is the nature of inductor. Opposite, obviously opposite will be the capacitor. Capacitor will be it have certain time to charge and discharge. If suddenly changing, high frequency waves are included means XC is equal to 1 by C omega, right? So high frequency waves are included means XC will be very low. XC will be very low means it start like a short circuit condition. It can't afford that type of changes. It simply in ideal form, okay, array, up chahiye. From my side, I won't disturb you, up chao. This was the condition regarding to what? Capacitor. Regarding to capacitor. Okay. So that's all. It's funny, right? It's funny, right? So we have to draw the figure again at t is equal to 0 plus condition beta. Listen carefully. The figure will be slightly modified, like the figure will be slightly modified, right? 200 volt and 40 ohm wrapped. The inductor will be short circuit. I mean open circuit. So this will be VL of 0 plus, right? VL of 0 plus, CL of 0 plus, and the capacitor will be what, beta? Simply short circuit, and there will be VC of 0 plus. There will be VC of 0 plus and 40 ohm. Okay, very interesting question, but a very interesting question. Correct, right? Correct, right? Yes. Is it clear? Up to this, is it clear to you? Up to this, the next figure I can write. Here I can, okay, I can draw here. I can draw here. It's very interesting and funny, but through fun only we can study better, right? So this is nothing but at t is equal to 0 plus. So what is VL of 0 plus? What is VL of 0 plus here? What is VL of 0 plus, beta? What is VL of 0 plus? There is a current, no? There is a current of 2.5 ampere, right? There is a current of 2.5 ampere, right? This current is also there, no? This current is also there, no? Only if short circuit, their effect will be gone. But if you open circuit, means that current will be there. That current will be there. That 2.5 will be there. So what is the value of VL of 0 plus now? See, this current is same in this 40 ohm also. So what is the voltage drop across this? 40 into 2.5 is nothing but beta 100, right? 40 into 2.5 is nothing but 100. So 100 volt will be the drop here. 100 volt will be the drop here. Total here to here it is 200 volt. Total here to here it is 200 volt. So 100 voltage from here to here means remaining here to here, that is nothing but VL of 0 plus is nothing but 100 volt. Right? Did you get my point? Did you get my point, beta? It's very important, beta. It's very important. So that means this 2.5 make this voltage drop as 100 volt here across 40 ohm. So total is nothing but 200 volt, right? So from this 200 volt, 100 volt dropped here. So remaining volt will be dropped here also. That VL of 0 plus is nothing but 100 volt, right? And this VL of 0 plus, beta, 100 is nothing but, or VL of 0 plus nothing but, inductor voltage is nothing but, I can write like L into d by dt of IL of 0 plus. This is correct or wrong? VL is nothing but 100. VL is nothing. Voltage across the inductor is V is equal to L into d by dt, right? So 100 will be equal to L into d by dt of IL of 0 plus, correct or right? We have to find this d by dt of IL of t, IL of d by dt of IL of t at t is equal to 0 means d by dt of IL of 0 plus, right? That is the meaning, right? So we have to find only this. We have to find only this. That means 100 by, what is the value of L here? 2 is equal to d by dt of IL of plus IL d by dt of IL of 0 or d by dt of IL means nothing but the unit will be what? 50 ampere per second is equal to d by dt of 0 plus. So that is the final answer. That is the final answer. 50 ampere per second, because di by dt is nothing but ampere per second. Unit is ampere per second, right? Ampere per second, right? Did you get the problem? Exact problem. Did you get that? How beautiful the problem is, how difficult the problem is, and see, it's very important problem. See, itana lengthy question, no? This much lengthy question will not be asked. Definitely will not be asked. I know that, but a portion of this will be asked. A portion of this will be definitely asked. Like VL of 0, sorry, VC of 0, IL of 0, like that, no? That type of question will be asked. So can I rub this? Did you get? Is there any doubt? If you have any doubt in my teaching or in my sessions, please comment on this comment section, okay? Don't hesitate to comment. If it's anything wrong with me, I mean the concept regarding the values or regarding the problems, please mention in the comment box. Please mention. Okay. Then only I can correct and I can improve, okay? So most welcome that type of comments and all. Okay, write another question. See, the switch may be at any position, right? Depends upon our leg. Depends upon our leg where it should be. We can't predict and all. We can't predict. Find V across switch at t is equal to 0 plus. Find V across switch at t is equal to 0 plus. At t is equal to 0 plus. Okay, draw the figure. Draw the figure. Draw the figure, beta. Okay. How can we find? How can we find V across switch? That means we have to find this voltage at t is equal to 0 plus, right? T is equal to 0 plus. That means in open circuit condition, no issues there. Okay, the first step is nothing but at t is equal to, what is that? 0 minus, right? 0 minus. In order to get the initial condition. So at t is equal to 0 minus, what is the condition? L will be what? L will be initial, I mean steady state condition means L will be short circuited and C will be what? Open circuited. That you have to write, okay? Open circuit. So our figure will become at t is equal to 0 minus means the switch is in closed position now. At t equal to 0 only it will be in open. At t is equal to 0 plus means the switch is in closed position. I mean this whole session will be closed, I mean shorted. So these also get shorted. There is no need to include this because it shorted means this also shorted. So resistance will be 0 now. This is shorted means this also condition shorted. Parallel resistance will be same, right? So this will be shorted, this will be shorted. So only this will be there. This is shorter now. So this is shorter. And inductor will be what? Short circuited. Capacitor will be open circuited. So inductor will be simply short circuited. If inductor is short circuited means there will be, we have to find IL of 0 minus, right? If whenever inductor is short circuited, initially we have to find IL of 0 minus. So this IL of 0 minus is nothing but beta, what is that? 20 by 20, right? It will be equal to what? 1 ampere. 1 ampere. 1 ampere. Next step is we have to draw for what? Next step is what? At a t greater than 0 condition. So you have IL of 0 in your hand, right? IL of 0 minus in your hand, right? So at a t greater than 0 means the switch is in closed or open position. The switch is in closed, open position, right? At t is equal to 0, the switch get opened. So at a t greater than 0 also the switch is get in open condition. So the figure will be listen carefully. It is in open means there will be an inclusion of this 10 ohm. Of course this C, there will be an inclusion, and 20 ohm there will be that, and the inductor will be there, and initial current, that is nothing but 1 ampere also will be there. The 2 Henry is the value of inductance. Listen carefully. So this is nothing but at t greater than 0 beta, at t greater than 0, right? T greater than 0. Correct? And one more thing you have to note here, that even though it is shorted means the value of the voltage, initial voltage across the capacitor also get what? 0, right? 0 volt. Very, very important. That also you have to note. Because this is shorted initially. For this condition, this is shorted means there will not be any voltage across the capacitor. That means capacitor voltage also, initial voltage also 0 volt. So this is nothing but there will be a 0 voltage in series. There will be a 0 voltage in series, but we don't need to include that because it's short circuited, 0 voltage understood. So this is, there will be 0 volt, simply it is shorted. No need to write that. So that is at t greater than 0. Okay, we have to find everything for t equal to 0 plus now. So at it t equal to 0 plus, that means soon after the transient happened, soon after the switch was opened, maximum interrupt will be there in the circuit. So at t is equal to 0 plus, what will be? Inductor will be open circuited, capacitor will be short circuited, right? Inductor will be open circuited and capacitor will be what? Beta? Short circuited, right? So what happened? The circuit will become, listen carefully, the circuit will become capacitor will be what? Short circuited. So no need to consider for that also, simply short 20. Inductor will be open circuited and there will be a current of 1 ampere, right? Inductor will be open now. So this is nothing but VL of 0 plus. But we don't need to find that VL of 0 plus and all. Initial problem also, in the previous problem you have to find, no need to write. If you write also, no issue. We have to find the voltage across the switch means, here is the switch now, across 10 and C now. This was the switch position now. This is represented by simply Vx. So we have to find the voltage across, suppose this is Vx. That means we have to simply find the voltage across 10 ohm. If this is 1 ampere means this also 1, this also 1, this also that. This also 1 ampere. No? Through this 10 ohm also 1 ampere. So voltage across, I will write here, voltage across switch at t equal to 0 plus will be equal to what? 10 volt. Because 1 into 10 will be 10 volt bus. Kadam Kali. That is the answer. So 10 volt will be the answer. Okay, correct. 10 volt will be the answer. Did you get my point, beta? Did you get my point? Is there any doubt? Is there any doubt? Is there any doubt? Is there any doubt? Can I wrap this? Okay. So that's all about the question. See, our aim is to solve a problem, right? So for that we can use any funny methods or funny things or funny talks or anything, no? Then only classes will be interesting, no? That's why. This can be taken if it is something funny there, otherwise it will be bore, maximum bore will be there, because transients are always bore sessions, right? Bore sessions. So light another question. Draw this figure and we have to find IC of 0 plus, find IC of 0 plus and VL of 0 plus. IC of 0 plus and VL of 0 plus. Correct. Find IC of 0 plus and VL of 0 plus. Okay. So how can we start with? How can we start with such question? So you can start with what again? At t is equal to 0 minus, in order to get the initial condition, right? So at t equal to 0 minus means the switch is in closed or open position. It's in open position, because at t is equal to 0 only it is come to close. So before that the switch was in open position, the switch was in open position, right? So this part will be excluded, right? This will not be there in the circuit, right? So this is up to this we can't, up to this we can remove. So at t equal to 0 minus means it simply contains, listen carefully beta, simply contains VL of 0 minus IC of 0 minus. This current is IC of 0 minus, this voltage across this is nothing but VL of 0 minus. I will write here, okay. If you collapse here, I will find here. Okay. So this is IC of 0 minus, you know, you will know, you are know. This is nothing but VL of 0 minus, right? VL of 0 minus. Amen. So this is nothing but 2 Henry, right? 2 Henry. 2 Henry. Okay. So this is nothing but at t is equal to 0 minus condition. So from here, is there is any source here? In order to provide some current, in order to provide some voltage, is there is any source? No. They are not mentioned about initial charge and all. So the initial charge is assumed to be 0. So there will not be any charge or voltage in the capacitor. So you can say simply that. You can say simply that beta. IC of 0 will be 0 minus equal to 0 ampere and VL of 0 minus will be equal to 0 volt. Very, very important. So at t is equal to 0 condition, you got 0 ampere current and 0 voltage across capacitor or inductor, right? So that is very important, because there is no source to provide such voltage or current there. It is source free, right? It is source free, no? Source free in the sense there will not be anything to provide some current or voltage, and they are not mentioned about initial voltage or capacitor or inductor, not mentioned there. That means the capacitor and inductor initially chargeless, right? Initially chargeless or magnetic fieldless. Okay. That is why IC of 0 minus will be 0, VL of 0 minus will be 0. And what is our next step? What is our next step? At t greater than 0. At t greater than 0, right? At t greater than 0 means, listen very carefully, beta. Listen very carefully. There is an inclusion of this switch, right, in the circuit, right? That means this 20 volt will come into play, the 6 ohm will come into play into the circuit, right? Because the switch is closed now. So our figure will become 20 volt, 6 ohm beta, 8 ohm. This capacitor can be represented by a capacitor in parallel with, in series with a voltage source, but voltage is 0, no? So no need to draw that source. So it is simply 2 farad, 8 ohm. Inductor can be represented by an inductor in parallel with the current source now, but the current is 0 ampere now. So no need to consider that also, simply 2 Henry. VL of t, and it is nothing but IC of t. IC of t at t greater than 0 condition. And we have to consider for 0 plus and 0 minus condition, right? That is nothing but at t equal to 0 plus. At t is equal to 0 plus means, I already told you that maximum interrupt will be there in the circuit, maximum transients will be there in the circuit, so that the inductor and capacitor will be come into play maximum. That means at t equal to 0 plus, inductor will be open circuit and capacitor will be short circuit, right? Inductor will be open circuit and capacitor will be short circuit. So draw the figure again. So it will become 20 volt, 6 ohm, 8 ohm will be, capacitor will be what beta? Short circuit. So another 8 ohm will be there. Inductor will be what beta? Open circuit. Plus. Capacitor will be short circuit mean at that time we have to find t is equal to 0 plus mean IC of 0 plus. Inductor is open circuit mean at that time we have to find the open circuit voltage of the inductor. That is the question. That is nothing but VL of 0 plus bus. So now you have to, our aim is to find the value of IC of 0 plus and VL of 0 minus bus kadam kali. Okay beta? Clear? Can you tell me what is the value of IC of 0 plus? What is I here? Simply I first. You have to find I first. What is I here? I is nothing but, listen carefully, I is nothing but 20 divided by this 8 and 8 now parallel, right? This 8 and 8 parallel, so resultant will be 4 now. So 4 plus 6, it is in series now. So 4 plus 6 will be 10. So 20 by 10 will be the resultant current, that is nothing but 2 ampere will be the resultant current. That means this current will be 2 ampere, right? This current will be 2 ampere, right? So what is this current? These 2 ampere split up into 2 parallel path. Volt current division rule now. So these will be split up into 2 path. So definitely this is 8 ohm and this is 8 ohm. So this will be 1 ampere. This also will be 1 ampere. No need to find. So the current through, though we can say that IC of 0 plus is nothing but beta 1 ampere. IC of 0 plus is nothing but 1 ampere, right? And what is VL of 0 plus? VL of 0 plus is nothing but voltage across this, right? Voltage across this means the voltage across this, right? If 1 ampere flow through this means there will be a drop like 8 into 1, it's nothing but 8 volt. Bas kadam khali. See, after doing some problems now, what about your confidence level? What about your idea? What about your clarity? And what about you feel about these transients? It is very easy now. It is very easy now. You did all this. You did all this along with me. It's very easy now. Even though whenever the switch, wherever this position of switch be, whatever be the initial condition, you know where to start, where to end, or what condition should apply, you know clearly now, right? That I already told you that only by problems, only by doing problems, this will be very, very familiar. This is like neighbors. No, suppose you shifted your house to somewhere else. Initially you will feel some hesitation, right? Because near to you all unfamiliar, right? Unfamiliar. You don't know about where the what chai wala, you don't know about where the stationery store and how or our neighbors will be. You don't know anything. So at that time you will feel very hesitated. You will feel really what unease. But when after some days, no, you will be slowly start familiarize all your surroundings, right? And at that time, no, after some days, no, some weeks, no, you will be relaxed. You can simply go through your street or something with a song, simply song, no, like that you can go, because you familiarized. You are not at all tensed at that time. Similar manner problems also. If you do it for first time, it will be very difficult to you because you are unfamiliar with the concept. If you slowly start attaching toward the problem, what happens? It will be very easy. That's the concept. Okay, beta. Let's do one more problem. My aim is to finish this transients today itself. Okay, maxima I will do. Let's do one more problem, beta. Let's do one more problem. Write a question. For find VC of 0 minus and VC of infinity. VC of 0 minus and VC of infinity. Okay, let's try this also. Correct is the superposition? Yes, correct. So from where can we start? When you give some transients problem at t is equal to 0 minus, you can start with. So at t equal to 0 minus, I already told you, inductor will be short circuited, right? Capacitor will be open circuit, right? So this will be at t is equal to 0 minus means the switch is in open position, right? The switch was in open position because only at t is equal to 0 the switch come into play, that is in closed position. So before that switch is in open position, so only this 4 ampere will be there. So capacitor will be open circuit or no, so you want to draw this. And this voltage is nothing but beta VC of 0 minus, right? VC of 0 minus. So what is the value of VC of 0 minus? What is the value of VC of 0 minus? Capacitor will be open. What is the value of VC of 0 minus? What is the value of VC of 0 minus? See, The capacitor is open, so that is why Vc of 0 minus I draw here. Vc of 0 minus means this, if there is no current flowing through the circuit, means there is no meaning of this 4 ohm at all. We can simply short this 4 ohm like this. You can simply do like this. Okay, so you can simply do like this, because there is no meaning at all if there is no current. This and this across this and this means across this and this, right? Across this and this means if you elongate this, across this and this will be the Vc of 0 minus. So across this will be nothing but across this also. So across this means this 4 ampere is going here and it comes here. So Vc of 0 minus is nothing but 4 into 4, which is nothing but 16 volt. 16 volt. Okay, so Vc of 0 minus is nothing but beta 60 volt. Then what is Vc of infinity? So for that we have to know again t greater than 0 condition. At t greater than 0, what happened? The switch is in short circuit. I mean this is in closed condition. This is short circuit means this also short circuited. This also short circuited. Everything will be shorted. Everything will be shorted means the voltage across this capacitor will be also Vc of infinity, right? No need to draw the figure actually. No need to draw the figure across, because everything will be shorted at t greater than 0 or infinity condition. So it will be 0 volt, right? Or you can say that at t greater than 0 also, after that also, if there is infinity means at infinity condition the capacitor will be again open circuit, right? Capacitor will be again open, so it will be open. But even if it is open, once it is shorted means this also shorted, this also shorted. If one portion is shorted and if one portion is open means the effective will be again shorted, right? Effective will be again shorted condition. So that will be the answer. That will be the answer. Okay? Did you get that? Okay, I think it's over. I mean, it's actually 2 or 3 problems are there. 2 or 3 more problems are there, but classes will be very lengthy. You will be get bored, right? So let's meet again tomorrow. Okay, so until then, revise these problems continuously. Not simply revise. You have to write in your rough note or something. You want to come write and study. So because then only it will be keep in your mind. I mean, all the time it will be in your mind, the steps and all. Only if you write and study. If you simply I know that. You know that at that time only. After some time it will not be there in your mind. But if you write something whenever you study, then it will be what? Persist for long time. Okay, so thank you all. See you again tomorrow.